Friends, you must have seen James Cameron's movie Avatar, and if you haven't, no worries. This film showed us all a dream. It featured a planet where everything, the trees, plants, and animals, glows in the dark. A place where 10-foot-tall blue beings called the Na'vi live, and where mountains float in the air without any support. When I saw this film, only one thought came to my mind. In our vast universe, could a place like Pandora truly exist? Is there an alien civilization based somewhere far away that we know nothing about? In today's video, we will understand this mystery from a scientific perspective. For centuries, humans looked at the stars and saw gods or myths. Today, we look at the stars and see data. The problem we face is a cosmic contradiction. On one hand, our mathematical models suggest that there should be billions of Earth-like planets in our galaxy alone. On the other hand, we haven't heard a single "hello" from the cosmos. This is the great silence. We are obsessed with finding a Pandora, not just for the sake of curiosity, but because of a looming reality. Earth is a finite cradle. To ensure the long-term survival of our species, we must find out if the biology we see here is a one-time miracle or a universal law. Why does it matter? Because if a planet like Pandora exists, it changes everything we know about our place in the existence. It transforms us from the masters of a lone island into citizens of a crowded cosmic ocean. To find a real-life Pandora, we first have to look at where the movie placed it. In the film, Pandora is a moon orbiting a gas giant in the Alpha Centauri system. In reality, Alpha Centauri is not just a name made up for a script. It is a very real, very physical place. It is our Sun's closest neighbor, located about 4.37 light-years away. To put that into perspective, light travels at 300,000 kilometers per second. Even at that unimaginable speed, it takes over 4 years for a beam of light to reach us from there. If we calculate the distance in kilometers, Alpha Centauri is roughly 40 trillion kilometers away. If you were to board the Voyager 1 spacecraft, one of the fastest objects ever built by humans, it would take you more than 70,000 years to reach those stars. While this sounds like an eternity in human years, in the context of the universe, Alpha Centauri is essentially our next-door neighbor. Scientists have been staring at this system for decades, and in 2016, they found something remarkable: Proxima Centauri b. This planet is roughly the size of Earth and, most importantly, it sits in the habitable zone. This is the foundation of our search. We now know for a fact that planets exist around our nearest stars, and some of them might just have the right conditions for life. The Goldilocks zone and Earth's big brother. How do scientists decide if a planet is worth investigating? They look for the habitable zone, often called the Goldilocks zone. Just like the porridge in the famous fairy tale, this zone is just right. If a planet is too close to its star, the heat will boil away any water. If it is too far, the water turns to ice. Life, as we know it, requires liquid water. This brings us to a planet often called Earth 2.0, or Earth's big brother, Kepler 452b. Discovered in 2015, this planet sent shockwaves through the scientific community. It orbits a star very similar to our Sun, and its year is 385 days, strikingly close to our own 365-day cycle. If you stood on the surface of Kepler 452b, the sky might look hauntingly familiar. However, the physics would feel very different. Kepler 452b is 60% larger than Earth, which means its gravity is significantly higher. On this planet, you would feel twice as heavy. Every step would be an exhausting effort. This tells us that even if a planet is Earth-like, the life that evolves there would have to be radically different from us to survive the crushing pull of gravity. The colors of alien biology. If we actually found a life-bearing planet, would we see blue people and green forests? The answer lies in the chemistry of light. On Earth, plants are green because of chlorophyll, which absorbs blue and red light but reflects green. But what if a planet orbits a red dwarf star like Proxima Centauri? A red dwarf is much cooler and dimmer than our Sun. To survive there, plants might evolve to be black or deep purple to absorb every single photon of light possible. What about the glowing plants of Pandora? This is a real scientific phenomenon called bioluminescence. On Earth, we see it in the deep ocean where sunlight cannot reach. Creatures create their own light through chemical reactions to communicate or hunt. If a planet has long periods of darkness or thick clouds, bioluminescence wouldn't be a rare beauty, it would be a survival necessity. Furthermore, life doesn't even have to be based on carbon like we are. Some scientists theorize about silicon-based life. Such creatures might look more like living crystals or rocks than biological animals. This realization expands our search. We aren't just looking for people, we are looking for any biological signature that defies the cold, dead laws of chemistry. The barriers of distance and time. The biggest obstacle in our quest to find Pandora is not our lack of imagination, but the laws of physics. As we discussed, 70,000 years to reach the nearest star is a dead end for human exploration. However, humanity is nothing if not ambitious. Enter Breakthrough Starshot, a project backed by late physicist Stephen Hawking and billionaire Yuri Milner. The idea is to build tiny, wafer-scale spacecraft equipped with light sails. Instead of using heavy fuel, these tiny probes would be pushed by powerful Earth-based lasers to 20% the speed of light. At that speed, we could reach Alpha Centauri in just 20 years. There is also the theoretical concept of wormholes, shortcuts through the fabric of space-time. If you fold a piece of paper, two distant points touch. If we can fold space, we could travel millions of light years in an instant. While this remains in the realm of mathematics and theory today, it represents the turning point in our technological evolution. We are transitioning from a species that observes to a species that aspires to reach out. Climax, the Fermi paradox and the Great Filter. Now, we reach the most chilling part of the documentary. If there are billions of planets and we have the potential to build such technology, where is everyone? This is the Fermi paradox. If the universe is 13.8 billion years old, why hasn't an alien civilization colonized the entire galaxy by now? It should only take a few million years to do so, a blink of an eye in cosmic time. This leads to the theory of the Great Filter. This theory suggests that there is a wall that almost all civilizations hit before they can become interstellar. Perhaps it is nuclear war, climate change, or an artificial intelligence that turns on its creators. Are we the first to get close to the wall, or are we the only ones who have ever survived it? The search for Pandora is, in many ways, a search for our own future. If we find a planet with ruins of a civilization, it is a warning. If we find a planet full of thriving life, it is a message of hope. It would mean that the filter can be passed and that humanity might have a future among the stars. In our search for a real-life Pandora, we have discovered that the universe is far more complex than a movie script. We have found planets in the habitable zones of nearby stars, like Proxima Centauri b. We have identified Earth's cousins, like Kepler 452b. We have learned that alien life might glow in the dark, or be built from different elements entirely. But more than anything, we have learned how precious our own home is. Earth is the only place we know of where the Goldilocks conditions are perfectly met. We have a moon that stabilizes our axis, a magnetic field that shields us from radiation, and a giant planet like Jupiter that acts as a vacuum cleaner for dangerous asteroids. We are looking for Pandora, but we must realize that we are currently living on a planet that is just as miraculous. Whether we find the Navi or not, the journey itself makes us a better species. It forces us to look up, to think beyond our borders, and to wonder. So, I leave you with this. If we do receive a signal tomorrow, should we answer it? Or should we stay silent and protect our island in the stars? The universe is listening. Hey everyone, most people watch the video but forget to like or subscribe. It actually takes a lot of effort to make each video, so your one like really means a lot. If you enjoyed this, please like the video, subscribe to the channel for more, and share your thoughts in the comments. Thank you.